Hey there, potential future physics pros. Welcome back to our channel. I'm Andrew. I'm here to talk to you about physics, and today we're diving deep into the world of forces and motion. At least just an overview of the importance of how those two ideas connect, because these are huge topics that go into kinematics, Newtonian laws, loads of stuff, mechanics. So it's a topic that's crucial for acing your GCSE exams, or at the very least just getting a basis of an understanding of physics. So grab your notebooks if you want to jot some things down and we can get started. So let's kick things off by understanding what forces actually are. Simply put, forces are pushes or pulls that can change the state of a motion of an object. But how does that apply in the real world? Well, I got loads of examples here, of that frictional force in play, that gravitational force, pulling them down, that applied force, that thrust he's putting on that trolley, the drag force, the air resistance opposing the parachute, the that restorative force from the spring sending upwards, the magnetic force of attraction there, the tensile forces, the buoyancy due to the upthrust, this interaction between the object and the force applied is what governs its motion and how it moves. So now let's talk about Newton's laws of motion, a fundamental concept you've probably already encountered in your GCSEs or whatever physics you're studying. Newton's first law states an object will remain at rest or in uniform motion, meaning it's going to stay the same, right? Unless acted upon by an external force. In simpler terms, that means an object tends to keep doing what they're doing unless something comes along to change that, right? So think of it like this. Look at this image I've got here. You're cruising on your skateboard and nobody pushes or pulls you. All right, you'll just keep rolling along at a constant speed. Now, obviously, there is going to be something that's opposing you. You can have the frictional forces at play, right? But it takes those frictional forces at play. It takes a force like a push or a pull to change that motion. Otherwise, you just remain at a constant speed. I've got this cup here that I'm putting on my hand, right? And until we have an opposing force acting on it, it's going to remain stationary. So Newton's first law is telling us that. Let's move on to Newton's second law, which relates to the force applied to an object, its mass, and its acceleration. As we can see in that equation that we've got there, F equals ma. This formula, F equals ma, tells us that the force acting on an object is equal to its mass multiplied by its acceleration. In other words, the more massive an object is, or the higher rate it accelerates, the more force is needed to move it, right? So imagine trying to push a massive box versus a lighter box, right? You're going to need to apply more force to get the bigger box moving, the more massive box moving at the same speed. And you can see that in the equation because the F and the M are directly proportional to each other. You can think about this in terms of your weight as well. Let me get the little goofy pen function. You can think about your weight, which is a force, right? Your weight is proportional to your mass, and it is proportional to how much you're accelerating due to gravity. W equals mg is simply just a contextualized example of F equals ma, Newton's second law. Your weight is equal to your mass and how much you're accelerating by. Your force is equal to your mass and how much the gravitational field is accelerating you by. Exactly the same thing. Finally, we have Newton's third law, which states that for every action, there is an equal and opposite reaction. It goes a little bit further than that. Yeah, if we really want to talk about this with a bit more clarity, a bit more resolution, I think it's a lot more powerful to say, let's make sure I get it right though. For every action, there is an equal, an opposite, instantaneous reaction on different bodies. So when you jump, you exert a downwards force on the ground. In response, instantaneously, The ground exerts an equal and opposite force on you, a different body, propelling you upward. So that's another example of every action, there is an equal and opposite instantaneous reaction on different bodies. And we've got another one in the image here, right? You push the wall, action. There is an instant and opposite reaction. Wall pushes back, right? And it's on a different body. It's pushing on you. If you don't believe that the wall pushes you, I don't know if you're probably at a desk or something like that. Take your hand and push it on the desk. You should be able to feel the desk pushing back. If not, you're going to need to develop the most basic mind muscle connection in existence. But you start pushing on that desk, you will feel that desk pushing back at you. You'll feel it do instantaneously, and you'll feel it be equal and opposite to the force you're putting in, right? So if you push harder, the table pushes back harder. Now, obviously, there's like a tensile limit to the table. There's going to be a point where the table breaks, and then this whole system's over. But yeah, that's what happens. Equal and opposite instantaneous reaction on different bodies. That's Newton's theory. And there you have it, folks. Forces and motion, they might seem complex at first, and they are a lot more complex than what we got into here, to be honest. But with a solid understanding of Newton's laws, these are like the building blocks, like the a priori to build everything else. And with these, you'll be more than well equipped to tackle any GCSE physics exam, and you'll have something that you can use in your future studies wherever you're going. So don't forget to hit the like button and the subscribe button for me to be a shill here for more tips and trips to ace your exams. Until next time, happy studying. I'm going to talk more about me next. So if you want to leave now, feel free. So So as always, your interest, your support, it means a lot. I am here. The intention of this channel is to educate and spread awareness of physics knowledge, especially those in high school and college. And if you've got any questions or need further assistance or you've got any requests for videos, just let me know and we'll get those on the go because we're building this place up. Here's all my links, which are in the description as usual. My link tree, the YouTube, you're already on it. The TES storefront has paid and free resources. There's the Twitter, there's the Instagram. If you'd like to buy me a coffee, or more specifically, give me money to buy running shoes, that's always appreciated because I am always burning through running shoes. Until next time, bye bye bye.